Okay, so hi everyone. My name is Flavio. I'm from Brazil, and this is actually my second talk here on PyBay. I'm replacing someone that couldn't come, and I'll talk about preventing headaches with linters and automated checks. Very happy to be here with you today, and hope you enjoy this talk. Here's my Twitter handle, and Vinta Software is my company. I work there. We are a Brazilian software shop that works mostly with Django and React, with clients mostly in the US, New York and San Francisco. And if you need any development help with Django or React, feel free to reach us. So I'll be talking about linters and automated checks. What are they? Why using them? How to implement them? When to run them? And which ones exist? This talk is more focused on Django checks. Even though you don't use Django, this talk will also be useful because I'll give a general idea. Because originally this talk is for the DjangoCon conference, which starts today, and I'm going there right after here. So what are those things? Linked. In real life, linked are those things that you have on your shirts, and we all hate those things. If you go to the dictionary, you see that links are clingy, fuzzy fluff that accumulates, and we hate. That last part, I added it. You can check on Wiktionary. And a linter is this. I really recommend this thing here. I have one of these, and it really removes the links. And this is also valid for software. A linter is a tool to analyze code and find flaws and errors, helping to remove that clinging, fuzzy fluff we hate. For me, it's very difficult to pronounce this thing, but it should be like a clinging, fuzzy fluff. It looks like a good indie band name or something. So if someone is looking for an indie band name. So these are linters, are tools to analyze and find flaws and errors. And just a quick example, you have here a code, mysum.py, and you have an error there, which is the x argument, the x parameter is duplicated. So if you run pyflakes on it, it will see that the argument is duplicated, which is wrong, and you have an undefined name because you never declared y. Okay, so you may know that this is what linters do, but you may not be convinced. Hey, I don't need these on my workflow. This is just for coding time, or if I have good tests, I'll detect those things, so I won't need them. Yeah, but what's wrong with this code? People who work with Django here, can you see something wrong with this code? Yep. Exactly. You have to return the query set after doing a filter operation over it, because query sets always return are like expressions. The filter method is like an expression. You need to assign it again or return it. So if you look at a quick glance, there's nothing wrong with this code, but a linter could detect this. Can a really linter detect this? Yes, and we'll see how. But first, let's see that linters can prevent bad style, and that's what pycodestyle does, for example. Can prevent bad patterns. You have flake8 bugbear for that. Can prevent real bugs like the one we just saw with pylint and custom link tools you want to write. And even security vulnerabilities, there is a linter for that called Bandit. I really recommend it. And expert developers know language framework library-related quirks and common mistakes. It would be great if expert developers wrote this knowledge down as linter checks to prevent them from happening, and perpetuating this knowledge through the form of automated checks. So for organizations, linters consolidate knowledge in executable form. And by this way, they enforce long-lasting good practices, they automate code quality checks, and also help to train new developers. And in fact, organizations are already doing this. You can check that Twisted, OpenStack, EDX, SaltStack all of them have custom linters on their repositories, and tools actually support that. Pycodestyle, Flake8, PyLint, Bandit, Koala, all of those tools support custom checks plugins that you can write to have custom checks on your organization, and by this way you can consolidate knowledge in the form of linters, preventing common bugs and mistakes that new developers make, or even you can make if you forgot to pay attention or the code review missed it. So linters make a better UX for libraries and frameworks because error prevention is good UX. And Django does that. Many people don't know, but Django comes built in with a thing called the system check framework, which you can run like this, python manage.py check. And doing this, you can find some bugs and some problems that your code has. So for example, here in this example URLs code, you have a duplicated namespace, app1, and if you run the manage.py check, it will detect this. So Django already comes built in with those checks, and this is good because it prevents errors. However, there are many checks that should be there and there aren't yet. If you look on the Django docs, for example, for an array field, it says that if you give the field a default, ensure it's a callable. So this is something that's on the docs, but not on a specific check. So you have to read the docs to properly use array field. If you pass a default of an empty list, and many people do that because they think it will create empty list for every new array field, it actually doesn't do that. It creates a multiple default shared between all instances of array field, and that's obviously a bad thing. So a suggestion for Django and for any kind of library, perhaps every ensure, remember to, don't forget, you put on the docs should be a check. And it would be great if the library or framework prevented mistakes by doing these checks for the developer. But how? How can we do that? We can do it either via dynamic analysis or static analysis. Dynamic analysis is performed by executing the code, not necessarily at runtime, but it has to execute the code. What do I mean by that? In order to work, certain checks need to be dynamic. They need to execute Django, for example. If you want to check for unapplied migrations, you need to execute Django and need to connect to the database, do the check, and leave. You don't need to perform this at runtime, like when a user is using the application, but you need to execute the code. And Django system check framework is dynamic. So for this problem that I just said, the one of empty default on array field, empty list, let's solve this with a dynamic check. Here I have a post model that has a default empty list, and I want to check that and prevent that with system check framework. Let's see that the app namespace wasn't unique, and I can fix that too here. It's the other error I showed to you. And I can save this, and I can run again, and no issues identified. So this is how system check framework works. It's dynamic because it needs to execute Django. So it needs to load models. It can connect to your database if you want. It can load your settings, or you can pass dummy settings to it. Anyway, you can use it as you want, but it needs to execute the code. But there is also static analysis, which is performed without actually executing the code. It's safer and more general than dynamic analysis, and it can analyze all code flows. So for example, when static analysis finds a if or a for or something that has a branch on your code, it can analyze all code flows. If enters the if and else it not enters the if. So it's similar to code review, but it's performed by machines. And there are many kinds of static analysis types, mainly these four. And first, the simplest one is text or regex-based static analysis. So you just check for a regex against your code, or if the code contains something. For example, there's a library, there's a linter called dodgy that looks at Python code and finds things that look dodgy, like passwords or diffs. You also have token-based static analysis. For example, this code here, this space here, is on purpose. It's something that we want to detect. And we can detect this with token-based static analysis. We just need to tokenize the code. And we see that there is one space between print and between the open parentheses. And therefore, we can detect this is a style error. And in fact, pycodestyle does exactly that on this function called white space before parameters that detects this. So token-based is better to get structure than raw text. It does not lose information. So if you tokenize a code and untokenize it again, it becomes the same code it was before. So this way, it's ideal for style checks. And pycodestyle, formerly called PEP8 tool, is part of Flake8, uses token-based static analysis. We have also the abstract syntax tree-based static analysis. Here I have an example of what's an abstract syntax tree. If I import AST and Astor, which is a library, third-party library to print, to dump ASTs better than default AST model, I parse it and then I dump it, and I'll see something like this, which is a tree structure for code. Abstract syntax trees come from parse trees, and it's part of the interpretation or compilation of computer programs, but you can also use that for static analysis. And here's basically the tree structure of the code. You have the module, you have the function inside the module, you have the arguments inside the function, you have the body of the function, which has a return and everything. It's a tree structure of the code. And it abstracts some info away. That's why it's called abstract. For example, if, elif, else becomes nested if-elses. So we lose information. It's not like tokenizers who don't lose information. This loses information. And it's ideal for checks that need to analyze the structure of the code as a whole. For example, checking relationships between code parts, like logic errors. For example, undefined name. Here's an example of PyFlakes. It detects that I haven't declared file on this module because it analyzes the module as a whole and all names that are inside the module. So it visits everything on the tree to detect that. So this is PyFlakes, which is part of Flake8 that can detect that. It's AST-based. And ASTs are made for walking. You need to walk through them to detect stuff. So you have this abstraction called node visitor that comes with the AST module, and you can define a node visitor class, and you define the types of nodes you want to visit. For example, here we want to visit all functions and print their names, and then keep visiting. So we call generic visit, and then we call visit over the instance of the class, and we'll visit all the functions of the code. That bug we had before, we can solve with AST walking. Here is the self-filter missing return or missing a variable attribution. We can solve that with AST. Let's see the code. So here I have the AST that I want to check, which is that code that I showed to you. The self-filter missing a return here. Just before that, we need to know that we will have to check for a call, which is a type of AST node, a functional call. And we also need to check for expression. Expression here is an expression statement. It's not a regular expression. It's an expression that doesn't attributes or return to anything. So we will look for expressions with calls that are made for filter inside our AST. So to implement that, we just parse the tree here. We define a node visitor. We put like here some of the methods that return query set, filter, exclude all, there are many others. And we then start to visit expressions, because that's what we are looking for, things that are expressions and aren't attributed to anything or return. So I need to visit expression. I need to check if it has a call inside it. I need to check if the called function is an attribute of a class. It's a method. So I need to check if it's an AST attribute. I need to check if that method returns a query set. So I need to check if its name is inside this list here, this set here. I need to check if it's called over a name, like self, and that this name is self. Then doing all of this, I can say that, hey, you have a query set expression that's not assigned, and I can print that to the user. So here is a code that you may write if you want to have those checks on your code. That's the idea. Like if you want to build your custom checks, you can write this code. And that's how the linters are implemented. So this is the check. It's looking at the code, looking for this pattern of an expression that returns query set and isn't attributed to anything. And also you need to check if you are inside a query set class, because you don't want to check for self-filter otherwise. And so to do that, you just need to visit the class definition and check if it's a query set based class. And you start to visit. And if you run that, if you run that, you see that the error appears here. Okay? And if I fix that by adding the return and run it again, we see that the error is gone. It's not printing anything else. So we are correctly detecting that kind of buggy code. That's great, but what if we had this? Instead of call over a name, like self-filter, we had like an expression before the call. Like we're calling authors first, and then we are filtering for admin authors, but this admin authors code is still wrong. We are not returning this. So instead, we are not detecting this because we are detecting self.filter. We are not detecting if the expression before the filter returns a query set, and it's not attributed again. So this is more difficult, because we have to do some inference here. We need to detect that self.authors returns a query set, and if a call over a query set also returns a query set, then we need to return it again. This is more difficult, and our code can't detect that. Would be great if we could infer the type of self.authors call. And actually we can. We can with inference-based static analysis. So inference-based means that we can infer info from the AST. We can infer things like imports, variables, attributes resolution, literal operation results, classes method resolution, or the types, many kinds of things we can infer just by looking at the AST. And it's like an interpreter that doesn't execute the code. An example of a linter that does that is PyLint. PyLint has very bad defaults. So if you install PyLint and run it against your project, you'll find lots of bad warnings that you don't care about. But it does has very good warnings related to bugs, because it can infer things from your code. And that thanks to the asteroid lib. And let's see a demo for that. Here is the code that we saw that the other AST detection can't find, and we can build it with Asteroid, the library I just said that PyLint uses, and we can make like a visitor, like the other one we saw, that visits the expressions, and we just need to check if the value of the expression is a call, and then we infer the call value, we infer what this call returns. And if this call returns something that's a query set, it's probably because you are forgetting to assign this query set expression. Because you don't want to call filter and don't assign it to anything. This like 99% of a chance of being a bug. So if you do a call inside an expression and you don't do anything with it, then and this call returns a query set, this is a bug. So this is the code that detects this. It's as simple as that because it has inference capabilities. You can infer what the expression returns. And if you run this, if you run, we'll see that we are printing that we inferred a person query set instance, and we see that the query set expression is not assigned. And if we fix that, by adding return here, we see that the error is gone. So it's great. Asteroid can make inferences from our code. But since the query set code from Django is quite complex, we have like to teach Asteroid how to infer from it. So that's the bad part, but it works fine. We just need to transform the query set on Asteroid to teach it how to infer from it. So for example, we need to check if we need to visit all calls from Asteroid. Okay, we need to see if it looks like a query set method call. And this is similar to what we saw before. We check if the function name is over methods that return query sets. And we give an inference tip to Asteroid. We say, hey, if you see something that looks like a query set method call, then infer that it returns a query set too. So to do that, I just check if the instance of the call, like the self value or the anything that's before the call is a query set, and you are making a filter exclude all the types of query set returning methods, you again must know that you are getting a query set again. So we are teaching Asteroid to make this inference. It's not a lot of code. It's a bit difficult to write this at first, but it's easy to get used to this. So we are teaching Asteroid to inference query sets because the query set code is quite complex for it to inference alone. But for simple code, for code that doesn't use magics like setting locals or like using complex meta classes or this kind of stuff, Asteroid can inference from you for you. And for real, this is something that we are trying to build at Vinta, a tool to find Django bugs like these ones. And we are just starting this project. So if you are interested in finding that kind of bugs, check this project. We are trying, like I said, to consolidate the knowledge we have about Django. Being Django experts, we want to consolidate that knowledge in the form of linters. And that's what we are trying to build there. What about mypy type inference? MyPy has type inferencing capabilities. What about them? Can't we use them to help Asteroid? Or can't we just use them instead of using Asteroid? Unfortunately, not yet. I asked this on a GitHub issue of MyPy. It would be great to have a specific API for the type inference capabilities of MyPy. And Guido agreed that this would be very useful and very powerful, but it's not there yet. There's something that they aren't expecting to work in the near or even medium future. But at the first night, we had a static panel discussion about types, static types panel discussion, and the library authors of MyPy, PyType, and also PyCharm are interested on this, and hopefully we'll get soon an API for type inference using type annotations, and it will be much easier to write code that needs type checks, like this one that detects missing query set expression attribution. Okay, so when to run these kind of checks? We need to run them like during the whole development flow, from programming time, commit time, continuous integration time to code review time. Programming time, like it's very easy. You just need to install those checks on your editor. Our modern editors support most of the the Python linters. And this is very important, okay, to prevent bugs and to teach new developers. But there is also some stuff that should never be committed. This is a real website from the Brazilian government, and someone committed a conflict here. Okay, so besides code checks during the development, there is also some stuff that should never be committed. And for that, you have commit time checks. You have pre-commit for that. It's an amazing tool that can run linters before the commit. So if the tool detects a failure on the linters, it won't allow the commit to go inside the repository. You also need to have these checks on continuous integration times. For some reason, someone was able to commit, or they skipped the pre-commit checks, you need to fail your build if any linter report any issue. So put each of your linters in a line of your continuous integration and check for them all and fail your build if any linter report any issue. You want that, probably you don't want that for style checks, but for security checks you want, for flakate you want, and it's really important. Django React boilerplate of Vinta, Django boilerplate that works with Webpack and React has lots of linters there, and if you want to have an example of a project that has lots of linters and has everything configured, just check there. And also, you don't want to repeat yourself in pull requests. This is especially useful for open source projects where anyone can make a pull request. You can write a custom linter check for your pull request, and you can use a bot to comment the linter results for you. And you have this thing called lintifresh, which is a project from Lyft that can comment on pull requests with linter errors. So if someone makes a bad pull request, you don't even need to worry about it. You just leave the bot do the job for you. And which lints we have out there, which lints we can use in our code. There are many linters available. Linters for quality, for imports, for security, for packaging. You can wrap them all with Prospector, which is a Python-only tool. Or if you have a multi-language project like most of web projects that are JavaScript and Python, or any other projects that have multiple languages, you can use Koala, which is also a Python implemented linter wrapper, but it can run linters from all languages. It's really nice tool. And we must clean out of these things. That's why we created this list here, this huge list of linters. Okay, it's a curated list of all the linters I could find when I was building this talk. So this is available on GitHub, and feel free to contribute with this. It's vintasoftware/Python linters and code analysis. You can find many references there, many linters you can use on your code. And finally, some people criticize static analysis because they say that it can detect many dynamic stuff, and Python is very dynamic. But we must criticize ourselves on that too, because if it's difficult for code analysis to understand your code, maybe it will be difficult for your fellow developers too. So think twice about using too much magic. Think twice if linters are failing on your code, because you're probably doing something that's too difficult to understand. And that's it. Feel free to reach me if you have any questions, if you want to contribute with Django Book Finder. Is something that we're just starting to build. We want to, like I said, consolidate the knowledge we have about common bugs, common problems of Django into linters, and that way it will be easier to teach new developers and to run this against legacy code. You have the Python linters and code analysis list on GitHub. Feel free to contribute with it. And there are other Vinta talks available there. We just took part on DjangoCon Australia, PyBay, and I'm going now to DjangoCon US. So there are other interesting stuff there. Thank you. Questions? Feel free to. Good?
Thank you very much. Very good talk. I will use many of the linters you pointed on your slides. One of the things that annoys me with a lot of warnings in linters is that the fix is obvious, like for example adding a space after a comma or something like that. And I was wondering if you knew of any common protocol or common linters that for some of this check could automatically provide a patch for the source code. Because for contributors in an open source project, it's really difficult when someone made a pull request to say, well, but you have to fix these 50 things, and if 25 of them could be automatically fixed, that would be great. And I was wondering if you have any idea on that.
Yeah. Amazing question, and it's great because I have a slide for that. Fixers. So some linters have the ability to automatically fix the code, and this is amazing UX. So if the next step on UX for linters, I think, is to fix the code automatically. And like isort does that, it not only detects that your imports are wrongly sorted, but it also sorts for you. Autoflake does that, autopep8 does that. And it's great because Koala, that tool that integrates many linters into a single tool, it can integrate checkers with fixers seamlessly. So you can run Koala and it will say, hey, I found a bug here. Want to fix it? The fix is that. And you agree, you check the diff, you click enter, and it's fixed. So this is great, especially for open source projects where you want to have a better usability for people who want to contribute with your project. Okay. Any other question? Okay, thank you very much. Feel free to reach me.